Okay. Okay, so we're going to graph this function just by the methods we already know, just to review those methods. Okay? So we could start with long division. But let's just factor instead. Factor. What do we get? We get x plus 2 times x plus 3 over x plus 4. So what can we tell from this? Can we tell where it's 0? Give me a value of x that makes it 0.
-2.
Okay, -2 gives us a 0 here, and that multiplies the rest of the numerator, so the numerator is 0. Now we do have to be a little careful. If x is 2, is the denominator also equal to 0? No, it's 6. Okay? So the numerator is 0, the denominator isn't, so there's a 0 there, right? Okay? And similarly, if x is -3, and a 0 the denominator, at x equals -4. Okay? So vertical asymptote at x equals -4. Okay, what do we do next? And we did this a couple of weeks ago. I want to give it a little time to settle in. I didn't want to give it time for you to totally forget it. But every time you reinforce something you kind of knew before, you all of a sudden know it a lot better. So,
Figure out the positives and negatives.
well, we sketched the x-axis and we sketched the locations of the zeros and the asymptotes, right? So we have -4, -3, -2. This is a vertical asymptote, and these are zeros. So I'm going to designate it like this. I'm going to put x's here and here, indicating the graph's got to go through these points, and a vertical line here, indicating that the graph has to be asymptotic, vertically asymptotic to this. Okay? Now let's see. To the left of -4, is this thing positive or negative?
Negative.
Well, if x is a great big negative number, what can you say about x plus 2? Great big negative. X plus 3 is a great big negative. And so is x plus 4, right? So all three of your numbers have to be negative over here. And since we used a great big negative number, if I multiply a great big negative number by itself and then divide by that same number, what do I get? I get a great big negative number, right? Okay? If x is -1 billion, well, -1 billion and 2 is just about -1 billion, right? No, actually, -1 billion plus 2 would be -999,999,998. Right?
Sounds like -1 billion to me.
Pretty much just -1 billion, so would this be, and so would this. It's like you got -1 billion, -1 billion divided by -1 billion. This one divides this one, gives you something real close to 1, and this one's left over, right? So we, incidentally, in thinking about this interval, we've discovered that the end behavior on this end is it's going to go way down fast. Or it's going to go down. Okay, so I'll indicate that for the end behavior. That might not curve down, Matter of fact, since the degree of the numerator is 1 greater than the degree of the denominator, it doesn't curve down, it goes like a straight line. Okay? Okay, well, now between -4 and -3, well, you do the same thing. You find that between -4 and -3, now this one is positive, but these two are negative. So you have a plus, plus, minus. So over here it's minus, over here, in this interval between here and here it's plus, and then between here and here it's going to be plus, minus, minus. Wait a minute. Yeah, I got this one wrong. I'm just being ignorant. Minus, minus, plus. Okay? So it's plus. And then it's minus, plus, plus, which makes it minus. And then for a great big positive number, well, this is positive, and this is positive, right? So it's positive, positive, positive. And if it's, you know, more or less equal great big numbers like this, it's going to give us a great big positive, so it's going to go up here. Now we can draw a graph, right? Now we might be tempted to draw a graph like we did earlier. I'll draw one kind of light. We might think it looks like this. And if that's what you drew, I would give you substantial partial credit. You'd only lose a little bit. But you would lose a little bit because now you know, if you think about it, that dividing this into this is going to give you a linear function plus something that approaches 0. Oh, actually, yeah, what I just did was totally ignorant. If you drew this, you'd have a serious penalty. Okay? Although you have the positive and negatives right. Okay, I wasn't thinking, but we got an asymptote here, right? Asymptote? Okay? So the yellow graph isn't much good. Still, you got good parts of it. I'd give you, might even get half credit if you drew that graph. Okay? So this graph is not a great, but not a terrible attempt. Okay? So I'll give myself a D- for drawing that. Okay? I'd give you a little better. Okay? Maybe even a D+. But you've been warned. Okay, we have an asymptote here. Now think about it. It's got to approach this line while it's negative, right? Got to be negative all the way up to here, and it's got to go way down here. So it's got to have an asymptote that goes down here. But it's also got to go down over here, right? So it's like we would draw the thing maybe like so. Now if you drew it like this, I would say that's much better. But you didn't get the fact that it has a linear asymptote, straight line asymptote. Okay? Much better, but not completely right. And over here, it's positive, so the asymptote has to come down from up here. It has to go through 3, right? Then it has to go through 2 and on up, so you might well draw it like this. Okay? Now the good graph that you would draw, the better one, we come over to the y-axis, and say, okay, here's our y-intercept. What's our y-intercept of this graph? Well, I'm not going to go that far. I'm just going to say, okay, this graph has to have a horizontal asymptote. And the way it's going to look, if the horizontal asymptote looks like this. Now this isn't quite right, because the way I drew things. Okay? That is not a horizontal asymptote. Here's our slant asymptote. Then our graph is going to look very much like this near the asymptote. But it's going to have to do this. Something like this. Then something like this. Okay, so there are 3 stages, at least, in drawing this graph. If you have the factored form of the rational function, you find the zeros and the asymptotes. They split up the x-axis into intervals where the value of the function doesn't change. Sorry, the sign of the function doesn't change on any one of those intervals. You determine whether it's positive or negative on each interval, and you're off to a good start. If you get that much, you get some reasonable credit. Not great, barely passing, but still reasonable. Okay? Won't kill your grade if that's all you can do. Now, if that's all you can do and you can't, if everything you do is like that, then, you're not going to get a very high grade. But, you understand, okay? It is kind of tricky. Still, you get those pluses and minuses. Get that down, so that you know that. Then you actually draw a graph that has asymptotes, where the asymptote, and asymptotes where the asymptotes are supposed to be, and zeros where the zeros are supposed to be, okay? And reasonable end behavior. If you happen to miss the fact that you have a slant asymptote, well, you're going to not quite get all the credit. You're still going to get, pretty decent credit. Now, if you want to make a real good grade, you want to know that slant asymptote, but it's 3 steps. They're sequential. You got to do this, then you got to do this, then you got to do that. And hopefully, after thinking about it and doing some problems, you get it down. Okay? So that's kind of the process for rational functions. We've been over most of it, so it should be familiar. Okay? Slant asymptote's the only thing that's new.